Hey class, this is the video for lesson 85. This is our last lesson for this week. We're returning to equations of a line. Well, we're introducing the equation of a line. We're going back to doing a little graphing on a coordinate plane system. Let's start by looking at one of our standard algebra problem here. X plus 2 equals 5. In our last lesson, 84, I solved a two-step problem for you by where we're subtracting 3, and so I added 3 to both sides. Don't forget that if you're adding 2, how are we gonna solve that? We're going to now, instead of adding, we're going to subtract from both sides. I'm working this vertically, like we showed in our last lesson that we can do. Our 2's cancel. X is there without a coefficient. That makes it easy. 5 minus 2 is 3, and x equals 3. So when we look at this equation and we look at this solution for it, we understand that there is only one solution. If x plus 2 equals 5, there's one and only one number that x can be, and that's 3. Because any other solution for x, any other value that you would have for x would make that a false equation. And there's no other number you could put in there that would make x plus 2 equal 5 except for 3. All right, this is a new concept now. Let's look at the equation here that I've written over here in blue, right? Y equals x plus 2. This is an equation with two variables now, y and x. So in an equation like this, we don't just have, maybe one solution for y or x, but we can have a lot of different solutions, and I'll show you why. If, for example, y turned out to be 7, well then, in this example anyway, if we subtract 2 from both sides, we would get 5 there. These would cancel, and we would see that x is 5. Now you can just look at that, and when you see 7 equals x plus 2, you know that x is 5. Okay, but that's if y is 7. All right, so if y is 7, x is 5. But what if we say, oh, what if y is 9? Okay, so now we have 9 equals x plus 2. Just looking at it, you can see x is going to be 7 in that situation. Fill in my value there. All right, what if we decide to make y, 50? 50 equals x plus 2. And I subtract 2 from both sides, and I see that when y is 50, x is 48. So when y is 50, x is 48. And we could actually find out that if I kept on doing this, there's actually an infinite number of solutions to this equation for x and y, depending on when one value changes, then the other has a corresponding changed value. And so you can look at my chart down here and see that we can have lots of different values for x and y that would make this equation true. And they're pairs. So, 7 and 5 go together, and 9 and 7 go together, and 50 and 48 go together as solutions to that problem. One interesting thing is that if we were to take these pairs and graph them on a coordinate plane, we would get a straight line. All right, let's try that. They just happen to. Now, when you do a plane system, make sure you always put arrows, because these are actually representing infinite lines out into infinity. All right, and the center of our Cartesian coordinate system here is 0, and then you can draw some hash marks like that when you graph. I probably shouldn't have used 50. That's a little bit large. I'm going to put a different one in there. Let's make y, let's just make it simple. When y is 0. When y is 0, what is x? Oh, let's subtract 2 from both sides. And 0 minus 2 is negative 2. These cancel. So we see that when y is 0, x will end up being negative 2. All right, So let's try graphing a few of these points. They tell us it's going to be a line. Is it going to be a line? Let's see. Let's start with 0 and -2. Now, when you're graphing points, we have graphed points. I should have drawn this x and y. I'm going to flip my values. I'm just going to write it with x first because that's the way we're used to reading it. And I'm going to try another simple one when y is 3. When y is 3, x is going to be 1. I hope you saw what I did there. 3 equals x plus 1. What must x be? If y is 3, then x must be 1. Y equals 1 plus 2. So here I have 3 points. I'm going to graph -2, 0. Remember, we always do x first. X, this is the x coordinate, and this is the y. So x is the horizontal value. We go left to right, and then for y, we go up or down. It's the vertical value. So when we have the point right here, -2, 0, I'm going to start at the center, at the origin there at 0. I'm going to go to -2. This is -1, -2 in the negative direction. And then I'm going to go 0, actually 0. I'm not going up or down. I'm staying right there at 0. So that's my first point, right? That's -2, 0. Let's graph this one, 1, 3. All right, 1, that's my horizontal value. I need to go out to +1. It's right here. All right, and then I need to go up to 3. Let's count, 1, 2, 3. And that's where my point 1, 3 will be. Let's see. Now, it's a little hard on this whiteboard to draw a straight line, but if I connect those 2 dots, I'm going to get a line. No, that's not so bad. Okay, and that goes out into infinity in both directions. And every solution to this y equals x plus 2 is going to fall somewhere on that line. So if you look at 5, 7, you'd expect that to fall on my line. Let's see if I can, this isn't perfect or anything like that, but that way up there, that would be 7, perhaps. All right, so let's graph 5, 7, 1, 2, 3, 4, 5. That's my x value, and then I have to count up to 7. Let's go up here. It's going to be roundabout up here. You can see that, yeah, I mean, if this were perfectly drawn on graph paper, 5, 7 would fall right on that line. And every value that we can put in there for every solution for y and x that makes that equation true is going to fall somewhere on that line. And so this lesson, they're showing you how to find those points and graph that line. Let's see. So typically, when you have an equation, you know, with y equals x minus 3, we'll say. When you want to find the points that solve that equation, you're going to write x and y, x on the left, y, because our pairs are always x, y. This is x and y. And that's the order we go in when we're graphing them. So if I were looking for solutions to this equation, I would say, let's see, when y is, well, I drew a really long tail on that y. All right. When y is 5, what is x? Okay, when y is 5, well, x is going to be 8. Okay, when y is, let's see, when y is 2, when y is 2, I'm just doing this mentally, I'm not adding 3 to both sides, then x is going to be 5. When y is 0, when y is 0, 0 equals, that's going to be 3. So what you do is you throw in some y values and you ask yourself then what value for x makes that sentence true. All right, I could, you know, when y is 1, 1 equals x minus 3. What is x going to be? It's got to be 4. The only thing that makes that true is if x were to be 4, because 4 minus 3 is 1. All right, then I would come over to my coordinate plane. Try to do this fast for you. I think you get the idea. All right. It's y. That's x. I'm going to draw the hash marks, but I'm not going to label them with numbers. And obviously I'm doing this quickly for your benefit, so it's not perfectly spaced either. I recommend graph paper when you do this, but you can do it on line paper just fine. Just try to be neat and tidy about it. All right, when x is 8, I'm sorry, let's see. Our first point would be 8, 5. Probably shouldn't have done something involving 8, but I will. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, it's going to be right about there. Okay, that's 8, 5. Remember, x is our first value that we go left or right on the number line, and then with y we go up or down. So 5, 2 is going to be 1, 2, 3, 4, 5, and up 2. It's going to be there. What are you going to expect to see here? You're going to expect to see numbers that line up, or points that line up that all fall on the same line. 3, 0 is our next point right here. 1, 2, 3, and 0. I stay right there at 0. I don't go up or down. And our last point is 4, 1. Let's see, 1, 2, 3, 4, and that's up a little bit. Yep, you see those line up. Now, obviously, this would be a little bit squiggly, but if I were on graph paper, that would line up perfectly straight. I'm going to try to catch all those. Those actually all fall in the same line. So what they're trying to impress on you is that when you have an equation with two variables, that there are actually an infinite number of solutions. And that's when we get into some geometry here and graphing those solutions on a coordinate system. And we see that the solution for any given equation in x and y is going to be a straight line. Okay, and so let's see in your practice, what are they going to have you do here? Where is the practice? Yep, they just have you sketch a coordinate system. They're going to give you an equation with x and y, and they're going to give you the three variables they want you to use for x values. They'll start you with x values. It doesn't matter if you start with x or start with y. They'll give you three values for x, and they'll want you to find y, and they'll want you to sketch or graph those 3 points on your coordinate system, and then sketch your line. And that's all there is to this. Okay. Make sure you check the book too for example problems. If you forget anything, it's a great way to learn. Just review in your book using the example problems. All right, signing off.